In this part, we continue the project, developing the layout, refining tasks, and moving closer to a real engineering solution. Now a task for the plumbing team. I create a floor drain in the room, and the plumbing team will route the sewage pipes under the floor. My task here is to show the location of the drain pit. Sometimes it's enough to show just the location point on the layout plan. Now I relocated it to my layout drawing and added a simple annotation. One more task for the civil engineers. We need to define pipe supports, metal support structures that carry the weight of piping components and prevent stress on the pipes. For example, large valves like globe valves can be quite heavy. That's why we route the piping and add supports where needed. Supports are especially important near pumps because pumps do not tolerate loads on their nozzles. Heavy components can cause misalignment and damage the pump connections. Align supports in one line or in a single row. It saves space, reduces cost, and makes the layout look clean and professional. Remember, no equipment likes when loads are transferred to its nozzles. This is especially important when a valve, like a butterfly valve, is installed directly on the nozzle. In that case, always add a pipe support right after the valve. Now I add pressure gauges before and after the pumps. How are they typically mounted? First, we add a weldolet or a saddle-type connection on the main pipe. Then we weld a short branch pipe around 100 millimeters. At the top, we install a small fitting, usually a threaded coupling or half coupling, so the pressure gauge can be screwed in. DN15 is usually sufficient for pressure gauges. Sometimes DN25 is used for other instruments. As you can see, here I just draw a small pipe branch from the main line. But if you want everything to appear correctly in isometrics, you need to model all components properly, add the fittings, define them, and include them in the model. On top of the tank, I add a level sensor to show how a task for the automation team is created. I also add a pneumatic on-off valve to show the control concept. When the level sensor detects a high level, it sends a signal to the control system. The system then opens the pneumatic valve and starts the pumps to transfer the liquid from the tank. For the automation team, a process and flow diagram is also necessary. They needed to add their symbols, control logic, and connections between equipment and instruments. So when you prepare a task for automation, include two things: a P&ID scheme and a layout plan with equipment, instruments, and valves. Let's get back to the civil engineers and define where the pipe supports should be. For this task, we need to specify the support location, the load it must carry, the height from the ground, and also define the base plate needed for the support leg. How do we estimate the load on each support? A simple approach is to assume that each support takes half of the weight from the pipe section on both sides. When calculating the load, include everything that adds weight: pipe material, fluid inside the pipe, insulation, and heavy components like valves and instruments. If you select supports from a catalog, each type has its own dimensions: leg length from the pipe center, and base plate size. Make sure you check these dimensions carefully and match your supports in AutoCAD to those parameters. Otherwise, you may give incorrect data to the civil team, and the installed pipe supports will not align with the structural supports on site. The base plate location should be clearly shown in the plan layout, so the civil engineer knows its exact position. So I simply draw rectangles in the plan to represent the base plates. This works well when the number of supports is not too large. So, the tasks for this small unit are complete. Now we add a ladder to the top of the tank to provide access to the level sensor. And finally, we prepare one layout drawing that combines all plans and section views, just like in a real project. I create an A2 size sheet to see how all the views are arranged on it for better visualization. When preparing project drawings, frames are also required. This time, I'll just use a simple black frame. Documents that belong to this type of project include table of contents, design report or explanatory note, technical specifications, material list, PNID scheme, equipment layout, piping layout, section views, annexes if required. Align the views by their axes and ground levels to keep everything consistent. Add clear names to each view and indicate the scale. The idea of this drawing is simple. Anyone who takes it should be able to build this unit. The main elements, especially new or important parts, should be drawn with thicker lines. Secondary or less important elements can be shown with thinner lines. Very often in larger projects, equipment changes over time, and sometimes you forget to update the task. For the civil engineers, like foundations for tanks or pumps, the result? The foundation is already built, but when the equipment arrives, it doesn't fit. In this view, the main focus is the piping, so I highlight the pipes and draw the other elements with thinner lines. The idea is not to overload the drawing with dimensions, but to measure everything that needs to be clear. Sometimes we mark certain dimensions with a star and add a note that these values should be verified on site during installation. And the last thing, most piping projects require isometric drawings. So here, I quickly generate a basic isometric drawing. From idea to drawings, this is how engineering is done. If you found this useful, subscribe to the channel and leave a comment below.